So what we want to do today is to introduce you to our upcoming practical for organic chemistry. So there's two parts, in case you're not aware. So part number one is the pre-practical assessment. Now, I introduced this a few years ago, and the reason why I did it is apparently that they do this now at university for practicals. So that you have to do a pre-practical assessment. Obviously, you've got a copy of the practical with you, but the pre-practical assessment really is there to check, did you read this? That's all it is. Okay? So if you've actually gone through the practical itself, because it's an open book, you can really easily cover the pre-practical assessment. Okay? This is an open book task. But if you don't get ready, you won't be able to get it done in the time frame because, as you can see, there are a few pages, okay, to do with this. This is best done actually in hard copy, and you'll be doing it in hard copy next week because you need to write equations to a structural formula, and it's a bit easier to do it with a pen and pencil than the laptop at this point. Okay? Great, everyone got that? So pre-practical is on next week. Okay. So, what is our practical about? Well, I've got it laid out on the board here behind us, as well as sitting up there, if you've got the file open. And so, what we're going to do is we're going to make an ester. That's the function of the practical next week. That's the purpose behind it. Now, we haven't talked a lot about esters. Esters are typically chemicals that smell sweet, and they also have a sweet taste. They're not actually a sugar or a carbohydrate's different structure, but esters are noted for their sweet smelling. So the smell of strawberries, pears, apple, pineapple, all those nice sort of odours that we smell and taste, they're based on an ester functional group. Okay? An ester functional group. Now, one of the questions in the pre-practical, I think, is for the ester that we're going to make next week, and we're going to name it in a minute, okay, our ester is going to be called butyl ethanoate, is the ester that we're going to make in the lab next week. So you need to look up the odour for butyl ethanoate. Okay, so what does it actually smell like when you make it? Doesn't always work out like that, mind you, but this is the odour that we're aiming for. Alright, general ester preparation. So when we're making any ester, it's always the same. An alcohol mixed with a carboxylic acid to make the ester plus water. However, there's two things that you need to be aware of. And these are words that I'm going to introduce that I haven't talked about much in the course before. The first thing I'm going to talk about is this. Catalyst. So we use concentrated sulfuric acid as a catalyst. And concentrated sulfuric acid is something that you probably don't want to get on your hands. That's why we do it in the fume hood over there, okay? And you're very careful about how you handle the acid. You only use a few drops of it to start the reaction off, but we use concentrated sulfuric acid. Pick it to me what a catalyst is. What is a catalyst, Rocco?
Speeds up the reaction.
Good. Year 8, Year 9, science. Speeds up the reaction. So the catalyst, and you notice in the forward direction, is acid. Concentrated acid. That's the first thing you need to take note of. The second thing that you know with this preparation is it's got an arrow in the forward and the backward direction. Do you remember what we call those reactions? Reversible. Is that what you're going to say?
Yeah.
Good. Grace? It is a reversible reaction. Yeah. But we also use the word equilibrium, year 12 concept. Okay? So the reaction actually goes forward and backward at the same time. So we've got a problem. As soon as we make the ester, okay, and the bell stops obviously, it starts to react with the water and it goes back to make the alcohol and the carboxylic acid again. We can't avoid that. Okay, it's going to happen. And so, if you think about it, the reaction is never going to go to what we call completion. It's never going to be 100% to the right. And that's why when you start this experiment, you've got to take note of the mass of one of the reactants that you start off with. Okay, it doesn't matter which one, but you've got to make sure you measure the mass of one of the reactants, because we're going to actually record the yield of the product at the end. Okay? Rocco, can you grab that shawl? So we're going to record the yield of the product at the end. You need to listen carefully. Yep. Just go through that door, man. Go through this door. Okay. So the next thing is, we actually do that in the lab. Alright? And there are 3 clear steps, and the 3 videos are sitting in the sector lesson for you anyway. So you could virtually not be here and see how to do the experiment. So the first step is what we call reflux. So we actually set everything up in a round bottom flask, as we've done all along. Okay? And using the procedure that is given to you, step by step, and we might change the volumes. I think we tend to change the volumes around a little bit. We'll cross that bridge when we need to. So following the procedure, there's a certain sequence of things that you have to do. So basically, you start off, it looks like, with your, what have we got? Your ethanoic acid. So we mix those 2 things together in the round bottom flask, and then we're adding the concentrated acid. And then we're going to wait for it to cool down. And then we start the reflux process. Have you ever done reflux before? Of course you haven't. Yes. Okay? You've never done reflux before. And so, when we actually use our kits, I'm just going to grab one now. So, when we grab our quick fit kits from the actual cupboard, we have got these, and we've used these before. If you can remember what this is called in term 1. This is called a condenser. Okay, it's called a Liebig condenser. Alright, and it's a hollow piece of glass, but it's got a jacket on the outside of glass, and of course the hose is for water to go in through the bottom and out through the top into the sink. So that's our condenser. We use a round bottom flask. I'll grab one of those. Hopefully this thing will follow me this time. And somebody's taking this glass, which is fine. I know where they are. So we use a round bottom flask, and we did that again early in the year. That'll sit on the bottom of our condenser. Okay. What we do then is we use a heating mantle. Some schools will use Bunsen burners, but we use heating mantles because it's no naked flame. And that sits there all day. Actually, it doesn't sit there all day. That sits there for about 40 minutes and it boils. Why would you do that? Why do we need to use a condenser for this reaction? Okay, let me take the condenser away. If I had a round bottom flask and I sat it on the stove or in a heating mantle and I heated it for 40 minutes, what would happen? Rocco? Who said that? It'd evaporate. It's going to evaporate. Okay, because we're turning the liquid into a gas. So we do not want to lose our product. Yeah? We don't want to lose it. So what we do is, by putting the condenser on the top of the round bottom flask, it's a pretty smart idea. It goes up the flask, hits the cold water, comes back down again. Up the flask, hits the cold water, comes back down again. So we actually reflux for about 35 to 40 minutes to start it off. Everyone okay with that? Okay? So that maximises our yield. Maximise means the most yield we can get. I'll tell you now that the yield we're going to get is only about 50% if you're lucky. Most students get about 40%, but 50 is pretty good. So we've got our condenser. Alright, the next thing that we're going to be doing then is we do this and then we pull the actual apparatus apart when it's cool, and then we do something called an extraction And probably another better word for extraction is to separate. To separate. Separate? How do you spell it?
Yeah, that's how you spell it.
You sure?
Separation.
Yeah.
Good? Okay. So we're going to separate out all the chemicals that we've actually got in this flask. Okay? So in here, we've got the alcohol, the carboxylic acid, the concentrated acid, water, and the ester. So then again, by the time we finish this experiment, we're going to have in there butanol, some unreacted, ethanoic acid, some unreacted, concentrated acid, the ester, and water. It's not rocket science, is it? It's pretty obvious. Just read the equation. So all 5 of those are going to be there. The first thing that we do is we add water to our products. The product is what's happened at the end of reflux. We add water to it. We're obviously going to get 2 layers. Any ideas? Why do we get 2 layers? Why do we end up with 2 layers? Can anyone explain? If I add water to this mix of chemicals, why do I get 2 layers? It goes back to... Noah, when does it go back to? When do we talk about things that mix together? We talked about it? Yeah? So, of all these things, if we're adding water, if things mix together, what do they have to be able to do? Patch. They've got to be soluble in water, which means they've got to be polar. They've got to be able to form H bonds with water. So of all these chemicals, which ones are going to be soluble in water? This is one of the pre-practical questions you've got to answer. Okay. This has got 4 carbons in it. Butanol. Is butanol going to be soluble in water? Probably not. Okay? Because it's got lots of carbons, it's not a very polar molecule. Ethanoic acid, soluble in water?
Yes.
Yes. It's vinegar. Vinegar dissolves in water. Okay? Small molecule, can H bond. Acid. Does acid dissolve in water?
Yes.
Yes, it does. Is the ester going to be water soluble? No. It's got no H's in it at all. It can't H bond with water, and it's not very polar either. And of course, we've got water. That's a no-brainer. So we're going to get 2 layers. Think about what's in the 2 layers. Okay? So we separate them. So we do this. We physically separate them. You see the video as I do this. I shake it, then I release the pressure, then I shake it again, release the pressure, we stop. Then I separate out the 2 layers, and I keep one of the layers. I'm not going to say which layer that I keep, but it should be obvious if you've read the experiment. Then we add to it sodium bicarbonate. Sodium bicarbonate, okay, is water soluble. It's a base. I add that. And I shake the sodium bicarbonate in here again. However, I get a build-up of... What do I get a build-up of? Sodium carbonate in here now with water. I'm shaking it, and it goes... Shake it again. Goes... Who's a carbon dioxide? Rocco. Why is it carbon dioxide? Because... Yep. Well, so would oxygen and hydrogen. Do we do a section on acids and bases?
No.
Or do I dream?
Yes.
Hayden, tell us why it is it.
Salted hydrocarbonates and acids. One of the reactants is carbon dioxide.
Carbonate plus acid. There's going to be still some acid present, gives carbon dioxide. So you've got to follow the sequence of the reaction. Again, that's the pre-practical assessment. What gas is given off? One of the questions. And why is it given off? Okay, so the extraction, obviously the why and the how. Okay, so why? Because we have to separate out as many of the reactants from the products as what we can. How? We do it with water first. Things that are water soluble get separated. Acids get separated. Then I'm left in the last step, pretty much maybe with the ester, We hope mainly the ester, but possibly some of the butanol, because we haven't been able to get rid of that yet. But I'll explain how we get rid of the butanol that hasn't reacted right at the end. Josh, you need to listen. The last step is, we put it into a flask. Normally we get to that point, and that sits overnight with fused calcium chloride. Fused means it's been melted or dehydrated. So the fused calcium chloride acts like a sponge. So if any water has got into here, into my ester, the last step is calcium chloride, put it in there. It goes like almost like oil at the bottom of the flask as it absorbs all the moisture from the ester. So another key point in the practical for the pre-assessment. Now, we've got our product ready to go. Last step is distillation. All right? And some of you may not have been here when we did distillation early in the year. So, to do the distillation, okay, we set up our apparatus. We've got our still head, okay, and we've obviously, maybe we'll do it properly, like that. Distillation is ready to go, you can see. All right, from there, round bottom flask is here. So, once we do our distillation, what are we looking for in the distillation? Because in the practical, I've given you some boiling points of chemicals to use. Why do you think I've given you all those boiling points? You're going to separate out probably the ester from the butanol. Okay? So the ester boiling point, it says, is 120 to 130. So at 125 or so, I'm going to collect the ester, we hope, and then I might collect it at 128, okay, degrees Celsius. That should be the ester boiling off and coming down the flask. Everything else on either side of that is not going to be the ester. So we're separating things based on their boiling point at distillation level. Everyone got that? But we would do that, we distill it once. So distilling is a way of purifying the product. And we're going to actually take our product and we're going to re-distill it again. What's the purpose of re-distilling it again? To make sure that it's pure. And then actually what we do is we really narrow the boiling point range down. So the first time we do this distillation, we might start collecting at 124, 128. Yeah? And then we keep that product. Not going to be very pure. We clean everything out, just with distilled water we come back again, and we're going to then have a distillation, but we're going to go to 126 to 127. We narrow the boiling point range down as the product becomes more pure. Theoretically, we could keep on going, okay, and we get down to, I think, 126 is the exact boiling point. However, there's a little bit of inaccuracy with our thermometer set up like that. So we don't want to throw all of that product away. Alright, so that process is going to be in the pre-practical. Alright, so it is really important that you understand what an ester is, how we make it, and all the steps involved. Because I'm not going to repeat that when we actually do the experiment. This is it. Okay? That's it. That's all you get.